Okay, sorry I had to go in two parts. My storage was having issues. All right, so you should have gotten an answer of 22.36 kilometers, and that's your magnitude of your resultant. Now, the thing is we don't have a direction for this. Now, this is where it'll be tied back to what we did in our last unit for projectiles, is we talked about, well, you have to know a particular angle. So we're going to look for this angle right here. What's super nice is we have all the sides for this. So you can use any trig function you want. I've told you before my preference is sine for whatever reason. So you could do sine theta equals 10 over 22.36. Make sure your calculator is in degrees. And for your angle, you will end up with 26.57 degrees. Now remember, we say this very specifically. We go north of east. And make sure you do that because you can't just say northeast. You got to say north of east in reference to your axis. Now what I want to do next is give you a few set of rules here for how to solve these kinds of vectors. And so, like you see on your paper, you can follow along, and I'm going to give you 5 rules. Okay? And these rules are simple. And again, I talked about this a little bit in our last unit. Rule number 1 is going to be to draw the horizontal vector first. Okay, so draw the horizontal vector. 2, draw the vertical vector. 3 will be then I'll ask to draw and calculate the magnitude of the resultant So there's your a squared plus b squared is equals c squared. By the way, I should put up here that these are 5 rules for adding perpendicular vectors. Okay. Rule number 4 is going to be to calculate the angle or the direction. So whenever I say angle or direction, I mean an angle. Okay. And then just as a reminder, you're going to list the angle as blank of blank, north of east, south of west, things like that. Okay. So now that we've done one, let's kind of combine a few things. Let's do one final example here today. Okay. All right, so this one's a little bit longer. I think I may have typed this in here too. Okay. You walk 15 meters east, 7 meters north, 18 meters south, and then 7 meters west. Calculate the magnitude and direction of the resultant displacement. Now you have lots of vectors here and you got to draw them all out. So we'll just go in order. So the first one goes, you go 15 meters east. Then it goes, you go 7 meters north. Then you're told it goes 18 meters south, followed by 7 meters west. Well, there's a whole lot of directions going on. Now, hopefully, again, when you look at it and you kind of think about everything that we've done this morning, you could look and go, oh, I have some ones that are, in opposite directions, and I can hopefully deal with those first. So the first two I look at is I look at this 15 and the 7 and go, they're going opposite directions, but they are 180. I can add those together. And if I look, 15 minus 7 gives me a horizontal vector of 8 meters to the east overall. So that's my resultant of those two. Plus, I have 7 and 18. Now they're going opposite directions, so I can also add those two together. And my 18 is bigger, so it's going to go south. Take 18 minus 7, and it goes 11 meters south. Oh, now I'm starting to see a triangle. This will work well. So now here's my resultant. Notice my horizontal I drew first, then my vertical. Here's my resultant, put an arrow on it. And this is what I'm going to look for, along with the angle from your horizontal. So again, to find resultant, when you have two perpendiculars, it's 8 squared plus 11 squared equals c squared. C will come out to be 13.6 meters. And then for your angle, again, you can use tangent, you can use cosine, sine, doesn't matter. But you can do sine of your angle equals opposite, which is 11 over 13.6, because that's your hypotenuse. And when you calculate that in your calculator, you're going to get 53.98 degrees south of east. And that's the math to it. Now again, just to show you a couple things, this is your resultant vector here, and our angle is always measured from that horizontal axis there. Okay, and that's all there is. There's a few more samples to finish up. Good luck today, and there I have a key on my desk. See you guys tomorrow. Bye.